Alright, so in case you were absent or you're virtual, I just want to go through a couple things I went through in class, and sometimes we breeze through them in videos, and I just want to make sure we focus on this. Alright, so, overlapping triangle proofs. Given triangle GHI is congruent to KJI, prove GHJ is congruent to KJH. So GHI are these two triangles, the outer ones. Alright, so what we want to get in the habit of is once they tell us triangles are congruent, all the CP. So those are all the sides. They're the easiest to label a lot of times. Okay? And now we're trying to prove GHJ is congruent to KJH. Well, that's where overlapping comes in. So there's that. Alright, so if I'm trying to prove that, I got that side and that side, and that side and that side. So I either need angles H and J, or I need sides HK and JJ. So we're going to show you both ways and then walk you through it, okay? So if you go with the sides, you'll notice that is a 3, that is a 3, that is a 1, that is a 1. That means their sums are congruent. Alright, so that means they're congruent. So we're going to start with our proof with triangle GHI, congruent to KJI, because it is given. And then basically we're going to go with all three sides being congruent. First way we roll through it. So GH is congruent to JK. Alright. GI is congruent to KI, the inner ones. And then the ones that make up the isosceles triangle on the bottom that we'll talk about in a second, HI is congruent to JI. From there, alright, we can say that GJ is congruent to HK, the bigger segments. Now, if you're going to struggle with what it is, write out what happens. So in this case, adding congruent segments to each other produces congruent segments. Alright, so if you ever struggle, so this was all CP. Alright, adding congruent segments to each other produces congruent segments. And that allowed us to say the triangle GHJ congruent to triangle KJH. Alright. And that would be side. That would be the most straightforward way of doing it. Alright, now the second way, perhaps, if we didn't want to use all the sides, and we'll walk you through it, is using these angles. Alright? So that triangle is congruent to that triangle. Alright? So that angle, first off, would be congruent to that angle by CP. And then those two angles would be congruent because the triangles are isosceles. Alright? And then basically, so if I'm going to do it that way, oh, we forgot something here. My bad. So we forgot HJ congruent to HJ by overlapping segments. That's what I forgot. The overlapping segment problem. Actually, not even overlapping. Why are we making it harder? Reflexive property or shared side. Okay? So now if I do it a second way, alright, so now I'm going to go with GH, it's congruent, JK, just like I did. I'm going to go with HI, is congruent to IJ, and I'm going to go with angle GHI, congruent to angle KJI, is CP. Then I'm going to say two things. First thing I'm going to say is that because HI is congruent to IJ, angle IHJ is congruent to IJH, alright, by isosceles triangle property. And then I'm going to say that HJ is congruent to HJ by the reflexive property. And that, ladies and gentlemen, combined with everything to tell me that GHJ congruent to KJH. Alright, by setting. So there's two ways to do that one. Again, either one's fine. Now the top one's a little harder, believe it or not. So they tell me EBF is congruent to EBD. So that's these inner triangles. Alright, and I'm trying to prove that these triangles are congruent. Well, those triangles have the BF, so I know I'm going to use that, BC, BD. Now everything else comes from something. Now AC is parallel to DF in the given. And then it says AF is perpendicular to DF, so that's a right angle. Alright, well that means, alright, and then they say AF is parallel to DC. Alright, well that means these two are also perpendicular, which means that's a right angle. These are right angles. Alright. And then basically, since these triangles are congruent, that angle is congruent to that angle, and that angle is congruent to that angle. Alright. So now I have that angle on that side, so the two triangles are going to be congruent. So now let's organize. So triangle EBF congruent to triangle EBD, given. Alright, and from that we use BF is congruent to BD by CPCTC. And then you may want to just throw everything together in the next one. AC is parallel to DF, AF is perpendicular to DF, AF is parallel to DC. Alright, now the rest of these, this next section can kind of come in any order you want. So the first thing we can say, because of that, is CD is perpendicular to DF, or FD, doesn't matter. Alright, this is given. Parallel lines are perpendicular to the same line. Parallel lines are perpendicular to the same line. Alright. So that means angle F, angle D are right angles. Definition of perpendicular line. Now I don't need those, so I'm not going to say they're congruent. But what I'm going to say is angle A and angle C are right angles. Alright? Angle A and angle C are right angles. Same side interior. Parallel lines, that's 90, that's angle. Angle A is congruent to angle C. Alright? All right angles are congruent. Now, up here, I'm going to go back because I forgot it with the CPCTC. I want to go with angle BFE congruent to angle BDE. Alright? Because that gives you a couple things. I can then say angle ABF congruent to angle CBD by alternate interior angles. Or I can say that angle AFB is congruent to angle CDB. Congruent complements theorem. Alright, and once I say that, I got my congruent triangles, ABF, congruent triangle CBD, alright, by either angle side angle or angle side. You don't need both. In fact, you don't need both parts of the proof. Now, the second part of this week's stuff that's been under the radar is isosceles triangles, and this is what it's due on Friday. Alright, so this triangle is isosceles, and that's perpendicular. Isosceles triangle properties then tell us that's the midpoint, and that this angle is bisected. So we got two parts of this. The midpoint part, which is a linear equation, 12x plus 9 equals 3/2x plus 51. If you don't like fractions, we can multiply everything by 2. 24x plus 18 equals 3x plus 102. 21x when I subtract the 3x from both sides equals 84 when I subtract the 18 from both sides, and x equals 4. If I plug that back in, that's 100. That's 100. This is 57, and that is 57. All right, which allows me to get the perimeter. Keep that in mind when you do work this week. Now the angle bisector becomes a quadratic. W squared minus 4W equals 7W minus 24. W squared minus 11W plus 24 equals 0 when I get it in standard form. W minus 8, W minus 3 equals 0. Makes my two solutions 8 and 3. Here's my problem. When I plug in 3, 7 times 3 is 21. 21 minus 24 gives me negative 3 for an angle measure. No good, so that's extraneous. So I plug in the 8. 8 squared is 64. 4 times 8 is 32. 64 minus 32 gives me 32. 7 times 8 is 56. 56 minus 24 is 32. All right. Now if that's 90, that's also 90. And we can use triangle angle sum. That would be 58. Now the one underneath, we got more isosceles triangle properties. This time the angles are congruent, so the sides are congruent. And that gives me my first equation. 7q minus 1 equals 6p plus 13. And now that tells me that the angle bisector means this is the midpoint. So those are congruent. So my second equation would be 8p minus 12 equals 3q plus 1. Now we can use any method we want to solve, but nothing seems to be giving me a variable with a coefficient of 1. So I'm going to look to use elimination. So I'm going to get 6p minus 7q equals negative 14 for that. And then I'm going to get 8p minus 3q equals positive 13 when I get that one in standard form. I'm going to take that equation and multiply it by 3. That equation multiplied by negative 7. That will give me a negative 21q there and a positive 21q there, which when I put them above and below each other, you will hopefully recognize that the q's when we add straight down will cancel out. I got negative 38p equals negative 133. And then when I'm all done, p is 3.5. Now it's your choice. If you're comfortable with that, you plug it in. 8 times 3.5 is 28. 28 minus 12 is 16. Do you feel good about the work and want to save yourself time? There's the other 16. When I plug it in here, 6 times 3.5 is 21. 21 plus 13 is 34. And if that's 34, that's also 34. Alright, or you could have plugged this back into any one of those equations, solve for q, which comes out to be 5, and then you can solve it from there. Alright, so everybody should be all caught up now with everything. Remember, this is the assignment that corresponds to this. The 5 problems is submitted in Google Classroom by Friday. Message me with any questions you might have. Stay healthy.